In this video, we're going to start with a definite integral and then write it as a Riemann sum. Let's do our first example. Write the Riemann sum that produces the same value as the definite integral from 3 to 5 of x squared plus 2x plus 1. Okay, so here's the limit definition of our Riemann sum, and I cover that in a couple other videos for this lesson. This is our f of x. This represents this piece here. However, the f of x is something being squared, 2 times something, and then plus 1. So we're going to plug something in to that f of x in a minute. But this piece right here next to the dx represents f of x. And we need to look at the inside of it here in a second. And that's what's going to go inside these little parentheses. Okay, that last piece at the end represents the delta x. In our case, delta x, in all cases, it's b minus a over n, but in our case, b and a represent 5 and 3. So that piece on the end is 2 over n. That'll always be the case. So when we write our limit definition, this piece is always there. It's a fixed part of the limit definition. So the things that you need to find are the delta x, which is given to you in the limits, and that always goes at the end. And then f of x is always the integrand, and now we need to figure out what's going to go inside of those x's. So the inside piece, the x coordinates, are a plus delta x times I. In our case, a is 3 and delta x is 2 over n. So you can take that, plug it right into those two pieces where it's x being squared and this 2 times x. This is what's going to go in to those parentheses. And there's your final answer. Okay, let's do another one. So now we have 2 times the square root of x minus x squared, and the definite integral from -3 to 2. Okay, again, there's our basic form. This is fixed. It's going to be in your answer. It looks exactly like that every time. The delta x is going to be b minus a over n, and our f of x is going to be this piece here. So now we have 2 times the square root of something minus this something being squared. So when we set it up and replace this with our f of x, it looks like that, where we're going to plug something in here and here. This is our x coordinate, and this piece represents the x coordinate. So let's start with that. Let's go to delta x next. b minus a over n. In our case, b is is 2 and a is -3. So 2 minus -3 ends up being 5 over n. And now the inside represents what goes inside those parentheses. That's our x coordinates. So a is -3, delta x is 5 over n. That is what goes in place of the x's here and here. So we are going to put this right inside of those parentheses. Right there and right there. Plug it in. So now you have 2 times this times the square root of this minus this thing all squared, because that's what our f of x is saying to do. Final answer. Not so bad. Let's do another one. Okay, so the integral from -1 to 1 of x dx. Okay, so again, here's our limit definition, the formal look of it. Our f of x is just plain old x this time. So when we set up our integral, we just have one thing that we're plugging in. Delta x is going to be from -1 to 1. So that's 1 minus -1 ends up being 2. The distance between them is 2. -1 to 1. Distance between b and a is 2. And inside, the thing that we're plugging in Oh, I'm sorry, I went the wrong way. The thing that we're plugging in, a is -1, and delta x is 2 over n. That goes right into the parenthesis there. And nothing is being squared or square rooted, like there's nothing crazy going on, it's just an x. So this is our outer function, and then this is what we plug into it. So you're all done.